going back to the vertex, we have gone a bit away from the vertex, but it's important that you understand this concept of how you add two numbers together and then you multiply them together as well. If you need to, go back and rewatch the video on factorization of quadratics. Let's just take the general term ax squared plus bx plus c and say we've rearranged it already and we've gotten it to 0. Oh, and additionally I should note that if c is ever equal to 0, for example you've got 2x squared plus 3x equals 0, then that's very simple. You can immediately factorize out that x, so x is either equal to 0 or x is equal to minus 3 over 2. But anyway, okay, ax squared plus bx plus c equals 0. I will show just with an example first the process of completing the square, then I'll go back to explaining it. So what if we had 9x squared minus 5x minus 2 equals 0. I could go, well this is going to be 9x squared minus 5 over 9x minus 2 equals 0. Then the next step is the part where you complete the square. You do this. Sorry, I made a mistake there. $648. 225. That's 3178. And now I can tell you that, well, even if we're just trying to find the vertex, we don't even need this to be equaling to 0. We can complete the square anyway, and then we can say that the vertex is at 5 over 18 minus 873 over 24, 324. But why? Why did I suddenly halve that like that? Just think about how we factorized. You know, when you, this here is equal to x minus 5 over 18, x minus 5 over 18, right? When you expand that, you'll get x squared, as you know, and then you would add those two together, right? And then that would be multiplied by x. Then you'd multiply those two together to get that c part. And then if you simplify this part, because it's half and two halves make a whole, you'll get 5 over 9x like you have there. But then you'll also have, annoyingly, that other part there, which is why you have to minus it again. But why does this suddenly equal the vertex? Well, think about it. Take a graph like this, and say it's x squared. You know, if you go 4 squared, you get 16, 3 squared is 9, 2 squared is 4, 1 squared equals 1, then add 0 squared equals 0. But then you go minus 1 squared equals 1, then minus 2 squared, that's equal to 4. It starts going back up again. So pretty much we know that when you've got that lowest point there, you want to try and get it to And you know that this is like your minimum point. It's a turning point. It can't get bigger or smaller. So we know that the smallest we can make this is if this bit was 0. Because if we made it anything less than 0, then you start getting a minus in there and squaring, which would be a positive, and it'd start going back up again. So we want that to be 0. So we get x minus 5 over 18 equals 0. That would make x equal 5 over 18. And then if that's equal to 0, then the whole function would just be minus 873 over 24, right? So that's why you got the vertex. And it would also work for, say, a negative 1. Say if it was negative 9, x minus 5 over 18 squared minus 873 over 224. Because suddenly if you start going this way, you get a negative in the bracket, you'd square it, making it a positive. But then you times it by a negative again, so it'd get smaller again. So that's why that would also be the maximum when this part equals 0. This is a process called completing the square. And the advantages it has is if it doesn't factorize, this is the way you can get x to appear only once. And it also gives coordinates of vertex. So, because x only appears once, it can be used to solve the equation. So we could go ahead and go, and if this was to equal 0, like I did before, you go like this. Then you'd divide. I chose some bad numbers for this, be very difficult to do. There's a 9. Oh no, that would go in there. 9873, that's 81 and 9, 63, 7. And then you take the square root. 97 is a prime number. And then don't forget your plus and minus. That's a 4. So then x will equal 5 plus root 97 over 18. Or x equals 5 minus root 97 over 18. So that's the process of completing the square. For a more in-depth explanation and the third way we can solve quadratics with the quadratic formula, please see the next video.